Hi everyone, this is Dr. Nak, and today we're going to go over section 11.4, hyperbola. So let's first go with the definition of a hyperbola. It says that the hyperbola is the collection of all points in the plane, the difference of whose distances from two fixed points called foci is a constant. So when I first read this, I was like, say what? So I will try my best to explain what the definition is telling you after we go over all these definitions, or I should say vocabularies below. There are two kinds of hyperbolas, which are the one that opens left and right, and the other kind is the one that opens up and down. So here, the picture is opening left and right. So let's see what we got going on here. So of course, we're going to have two vertex and two focus. Together, I believe that it's called foci. And oh my goodness, there's a lot of things going on here. So we have this thing called the conjugate axis and a transverse axis. Now the important part is that all the key points which are focus and vertex, they all must lie on the transverse axis. So in this picture, our transverse axis is the x-axis and the conjugate axis is the y-axis. So again, all the important points, vertex, focus, they all lie on the transverse axis, and there are things called the co-vertex. Now, co-vertex must lie on the conjugate axis. And we're not going to even end there. For the hyperbolas, we're going to have two asymptotes. Do not panic, we got this. So let's look at the very bottom of this page. It says equation of the hyperbola. So again, there are two kinds. The first equation is the hyperbola that's going to open left and right. And the second equation is for the hyperbolas that's going to open up and down. So what determines whether the hyperbola opens left and right or up and down? Look at the equations there. So notice that unlike ellipse, remember ellipse, our sign in the middle was plus. Now for the hyperbolas, our sign in the middle between x and a y, what I mean is it's going to be a minus. So it all depends on which variable comes first. So notice that on the top one we have x minus h. So x comes first before the minus sign. So in that case, our hyperbola is going to open right and left. Now for the second one, we have a y minus k. So the y comes first before the minus sign. So in that case, we're going to get a hyperbola that's going to open up and down. Okay, so those of you who will be taking calculus and whatnot and really want to understand what the definition of a hyperbola is, let me just recall what the book wrote. The textbook says, a hyperbola is the collection of all points in the plane, the difference of whose distances from two fixed points foci is a constant. Let's look at the first picture, the first graph. The orange curve is the hyperbola, and F and G are the focus, and P is the any point on the hyperbola. Now, look at the distance from F to P and P to G. There's some kind of a ratio going on there. So towards the bottom of the graph, do you see that the arrow pointing from P to F and then P to G? So basically, that is the length of P to F and P to G. Now let's take a look at the second graph. So again, F and G are focus, and P is a point on the hyperbola. So basically what I did was I dragged down that point P that was given from the first graph kind of towards downward along the graph of the hyperbola. Now notice the distance from F to G and G to P again. So on the bottom right there, we have the arrow pointing from P to F, and that's just the distance from P to F. And P to G, that's again the distance from P to G. So do you notice something here? Look at the first graph of the arrows and then the second graph. So basically, these distances are always going to be in the same ratio. With that said, let's take a look at the third graph. Again, F and G are focused, and P is a point on hyperbola. So from the second graph, what I did was I dragged up the point P a little bit along the the graph of the hyperbola. Now let's look at the distance or the length from P to G and P to F. So notice that towards the bottom, those arrows from P to F is the length or the distance, I should say, from P to F. And then P to G, that will be the distance or the length from P to G. So let's just focus on these two arrows for each situation. So to make the definition of the hyperbola in a little bit more simpler term, this just means that the distance from P to F is always less than the distance to P to G by some constant amount. And what's even cooler is that constant amount is nothing but the distance between the vertices. So for an example, let me just take the second graph. I'm going to jot down the two vertices, I should say, together. So these are the vertices. So that constant amount is nothing but the length from here to here. Now, if I chop this off at a center, this book says that from distance from here to here, which means the center, to one of the vertex is A. So center to another vertex is also A. So what's the total length? Total length is 2A. I think I just got carried away by trying to define the definition for the hyperbola, so I apologize if I confused the heck out of you. But now let's get back on track and talk more about the hyperbolas. So let's just summarize what we have learned so far. So the hyperbolas, we got the vertex, two focus, and transverse axis, conjugate axis, co-vertex, and two asymptotes. And please note that A is the distance from center to vertex, and C denotes the distance from center to foci. Now let's take a look at these two equations for hyperbolas. The first one, so again, if you look at the picture, C denotes the distance from center to foci. A is the distance from center to vertex. Now B is nothing but the distance from the co-vertex to center. We need those values for A and B because look at the equations. Equation requires that on the denominator we better have A squared and B squared. And same thing for equation 2. Every letter stands for the same things, distance from center to vertex and so forth. Alright, I think we're ready to do some examples, so let's do it. Example 1. Find an equation of the hyperbola that has one vertex at 0, 2 and foci at 0, -3 and 0, 3. Graph. So let's just plot points of what we're given. So we got one vertex at 0, 2. So this is vertex 0, 2. Please always label your points. And foci at 0, -3. So that's foci 0, -3, and then 0, 3. So 0, 3. Now, since one of the vertex is at 0, 2, and look at the distance between the focus and the vertex. It's just 1 unit, isn't it? So that means that other vertex must be here, which will be, what is that? 0, -2. All right. So remember that all the important points, foci and vertices, they all must lie on the transverse axis. Oh, and let's not forget the center. So it looks like our center is going to be at the origin. So I'm going to write center 0, 0. Now, since the transverse axis is parallel to the y-axis, we must use equation 2. So let me just write that out. Use equation circle 2, all right, which is y comes first. So we got y minus k squared over a squared minus x minus h squared over b squared equals to 1. All right, I think we got this. So ready? So let's first go with the center. So center is given by h comma k, but our h in this case is going to be 0, k is going to be 0. So h is 0, and then we got k equals to 0. Let me just box that. Now what's next? Let's go with the foci. All right, so foci formula for that will be h comma k plus or minus c. Again, you're going to be given this formula sheet, so don't worry about memorizing it. So here we're going to get 0 comma 0 plus or minus c. But remember, c was the distance from center to foci, or focus, one of the focus or foci. They're all the same distance anyways. So here the distance will be 3. So here we're going to have 0 plus or minus 3. So let me just make a note. C is the distance from center to focus. Okay, so in this case, we're going to get 0 comma 3 and 0 comma negative 3. Wait a minute, that was given to us. Dang it. All right, never mind. All right, whatever. Okay, so now who is next? Let's go with the vertices then. All right, the formula for the vertices is h comma k plus or minus a. All right, so in this case, we're going to have 0, and then k is 0, and then plus or minus. Now remember, a was the distance from center to vertex, so this is going to be plus or minus 2. So it looks like we're going to have 0 comma 2 and 0 comma negative 2, but we already know that because we already plotted those points earlier. But anyways, let me just box that. Okay, so first of all, our value of c is 3, and then our a is 2. So those are important values. Now, we still need to get the value of b. Now, how do you find that is this. This formula says that b squared must be c squared minus the a squared. So this is same thing as b squared equals to 9 minus 4, which is 5. So b must be square root of 5. Well, let me just box that in a different color, just like everybody else. All right, so now let's try to put the equations together, and what we're going to get here is, therefore, we're going to have y minus 0 squared over a squared, which will be 4, minus x minus 0 squared over b squared, where's my, square root of 5 squared, so which will be 5, equals to 1. So, simplify a little bit. So it looks like our equation is going to be y squared over 4 minus x squared over 5 equals to 1. So let me just box that because this is what we're looking for. All right, now since we're going to have to graph this precisely, we still got to get the asymptotes. So let's do it. So the asymptotes, the equation is y minus k equals plus or minus a over b, multiplying here by x minus h. All right, so now let's plug those values in. We got y minus 0 equals plus or minus 2 over the square root of 5 times x minus 0. So that looks like we're going to have, that's an arrow, sorry, y equals to plus or minus 2 over square root of 5 and then x. So if I punch this in the calculator, that implies that we're going to have y is approximately equaling to 0.9x and then y is approximately equaling to negative 0.9x. But let me just box all of this. All right, don't forget the positive slope and the negative slope there. All right, let's try to graph this out. You know my graphing skills, right? They're not the best, but I'll do the best I can here. All right, so let's first go with the asymptotes. So the first one is maybe approximately 0.9x. So the slope is 0.9 over 1. So rise 0.9 from the center and then over 1. So that will be like maybe right here. Oh my goodness. Okay, I can do this. I can do this. So I'm going to try to draw a straight line through here. All right, pretend that's a straight line. So this one is the positive slope. So this will be y equals to 2 over the square root of 5x. Now let's do the other one. So the other asymptote from the center, we're going to get somewhere around here. All right, let me try to draw that straight line. Not too shabby. So this is y equals to negative 2 over square root of 5x. Next, what I'm going to do is I'm going to draw this box that's going to go through the vertex and touches the asymptotes. So this is what I mean. So from the vertex, I'm just going to go like this. And then I'm going to go down until I touch the next asymptote. And then go through the vertex again. My gosh. And then I'm gonna go this way. Now look at the equation that we have obtained. Underneath the y squared, it's 4. So notice that along the line that's parallel to the y-axis, distance from here to here is 4. Here to here meaning the side of the box that is parallel to the y-axis is 4. Now let's talk about the other side of the length of the box. Now the length of the box that's parallel to the x-axis, if I drew this correctly, it should be 5. So the distance from here to here is supposed to be 5. If you drew this very, very nicely on a graphing paper, you will see that. So again, the length of the box that is parallel to the x-axis is 5. Okay, now the moment of truth. I'm going to try to graph this out. All right, so let me just go from the vertex and I'm going to go towards the asymptotes. I'm trying to draw an equivalent graph here. Hey, that's not too bad. That looks kind of good. All right, and then for the top half, I think this is like one of the most beautiful graphs I've ever drawn in this class. All right, so that is the graph of y squared over 4 minus x squared over 5 equals to 1. Let's do another example. Example 2, find an equation for the hyperbola with center 1, negative 2, one focus is at 4, negative 2, one vertex is at 3, negative 2, and we're going to graph this at the end. Just get an idea of what's going on. Let's plot what we're given. So center is going to be at 1, negative 2. And one focus is at 4, negative 2. 1, 2, 4. And vertex is at 3, negative 2. I'm just going to denote it as V right there. Hopefully you can see this. And then let's determine where the other vertex and foci is going to be. Remember, it has to be an equal distance from the center. So the distance from the center to vertex, it looks like it's 2. So I'm going to go 2 units to the left of the center. So it looks like the other vertex is going to be at negative 1, comma, negative 2. So I'm going to write it as V is negative 1, negative 2. And don't worry, I'm going to write it on the bottom. So the other vertex is going to be at negative 1, comma, negative 2. Now let's go with the foci. So the distance from the center to foci is 1, 2, 3. So we're going to do the same thing. So it looks like our foci is going to be right here, which is, what is that? Negative 2, negative 2. So the other focus is at negative 2, comma, negative 2. So it looks like our transverse axis is going to be parallel to the x-axis. So let me just write that out. This notation means parallel. Two straight line is parallel to the x-axis. So that determines which equation that we need to take. So in this case, we must use equation 1, which is x minus h squared over a squared minus y minus k squared over b squared equals to 1. Alright, now let's determine h and a k and an a and a b and a c. Alright, so let's first go with the center. Center is always h comma k, which is 1 comma negative 2. So again, h is 1 and then k is negative 2. Okay, so now let's go with the foci. Formula is h plus or minus c comma k. Alright, so then this is same thing as h, which is 1. And plus or minus c. Now remember, c was the distance from center to focus. So let me just write it. Center to focus. So in this case, what was it? C is 3. All right, let me box that. And then here we're going to come back and write foci is h plus or minus c. So you're going to have 1 plus or minus 3, comma k is negative 2. So we're going to have 4 comma negative 2 and what is that? Negative 2, negative 2. All right, so box this. And the vertices, what is the formula? H plus or minus a comma k. And now remember what a stands for. A is the distance from the center to the vertex. Let me write that out. A is the distance from the center to vertex. So in this case, it's 2. So let me just fill in the blanks. So here you're going to have 1 and then plus or minus 2 comma negative 2. So we're going to have 3 comma negative 2 and then negative 1 comma negative 2. So now we have, oops, I forgot to write a equals to 2. Now we have a and a c, so we should be able to get the value for b. Alright, so our equation for b squared is c squared minus the a squared. So b squared is 9 minus 4, 5 again. Alright, so that implies that our b is going to be square root of 5. Alright, I think we're ready to put the equations together. So, how about this? Should we just deal with the asymptote now? Might as well. So let's just compute the asymptote. Alright, so the equation is y minus k equals to plus or minus b over a and then x minus h. So here we're going to have y minus 2, so y plus 2 equals to plus or minus b is a square root of 5 over a is 2. and then x minus, what was h again? H is 1. So let me box that. Now let's look for the box. So the box is cool because we know that the asymptotes must go through those boxes. So from the corners of the box, I should say. So let me go with the box. So basically, what we need to do is, since our value of a is 2, right? So we need to go 2 units left and right from the center. So I'm going to write it as, from the center, go 2 units left and right from the center. And then, since the value of b was square root of 5 and b squared was 5, right? So in that case, we need to go square root of 5 units up and down. All right, let's draw the box. So from the center, we need to go 2 units left and right. So from the center, we're going to go 2 units to the left, 2 units to the right. All right, and then from the center, we're going to have to go square root of 5 units up and down. Square root of 5 is what, like 2.2, I think? So let me just go up approximately 2.2 units above from the center and below from the center. Now I'm going to draw a box using those 2 lines. So the distance from here is 4, and then this distance is going to be 5. Now the asymptote's going to go through from the corner to corner of that box. Here are the asymptotes. Now all you have to do now is determine which has a positive slope and a negative slope. So the one with the positive slope should be y plus 2 equals to, what is that, square root of 5 over 2 and then x minus 1. And the negative slope is y plus 2 equals negative square root of 5 over 2 and then x minus 1. All right, now let's draw the graph. So, okay, I can do this. So from the vertex, I'm going to go towards the asymptotes nicely. Not bad, not bad. All right, and then from this side, I'm going to do the same thing. We're done with the graphing part, but I forgot to write the equation of the hyperbola. So let's go back, and I'm going to take the equation that we wrote earlier, and then we're going to fill in the blank. So it looks like what we're going to get is x minus 1 squared over 4 minus y plus 2 squared over 5 equals to 1. So this is the equation of our hyperbola. Let's take a look at an example like this. Find the center, transverse axis, vertices, asymptotes, and graph of that equation. So guess what we need to do? Yes, we must complete the square. So let me just first rewrite this with x's together and the y's together. So I'm going to rewrite this as negative x squared and then minus 2x. And you know what? I'm just going to leave a little room because I know that I need to complete the square. And then here I'm going to have plus 4y squared minus the 16y. And you know what? I'm going to toss that 11 on the right hand side by subtracting it. So we're going to have this whole thing equaling to negative 11. Now the next step is this. In order for us to complete the square, the leading coefficient has to be positive 1. So from the x's, what we need to do is we need to factor out that negative. So I'm going to rewrite it as negative x squared and then plus 2x, and I'm just going to leave a room, and then plus, now for the y, we need to factor out the 4. So we're going to have 4 times y squared and then minus 4y and then equals to negative 11. All right, I think we're ready to complete the square, so let's do it. So first, let's complete the square on the x. So I need to divide the middle number by 2. Here you're going to have plus 1. So what I need to add is just 1 squared, which will be plus 1. But then if you're going to add in the 1 to the equation, you better subtract 1 to balance everything out. All right, so then if you want to take care of the complete the square on the x first, then this becomes negative, and then x plus 1 whole quantity squared, and then minus 1. Because remember, the first 3 terms become the perfect square. All right, now let's go complete the square on the y. Divide the middle number by 2. Here you're going to have negative 2. What goes in here is negative 2 squared. You're going to have to add that quantity in, which is plus 4, and then minus 4. So again, the first 3 terms going to become the perfect squared. So here you're going to have plus 4 times y, and then what goes in next is this number, by the way, minus 2 squared, and then drop down that minus 4 equals to negative 11. All right, now let me distribute that negative sign in. So let me go with negative x plus 1 squared plus 1, and then plus 4y minus 2 squared, and then minus 16 equals to negative 11. All right, so now what? Bring that 16 on the other side. So here what we're going to get is, how about we bring the plus 1 and then minus 16 on the right hand side by subtracting 1 and then adding 16 to both sides. So then here what we're going to get is negative x plus 1 squared plus 4 times y minus 2 squared equals negative 11 minus 1 plus 16. What the heck is that? Is that a 4? And at the end, we're going to have to make the right hand side equal to 1, so we need to divide every term by 4. Okay, so then what do we get? We get negative x plus 1 squared over 4 plus y minus 2 squared over 1, I guess, equals to 1. But let me just put the minus sign in the middle of the equation. So here what we're going to get is y minus 2 squared over 1 minus x plus 1 squared over 4 equals to 1. All right, so here is our equation of the hyperbola. Okay, now since the y comes first, we must use equation 2. So let me write it. Y comes first. Use equation 2. All right, which is y minus k squared over a squared minus x minus h squared over b squared equals to 1. Now from this equation, we can already tell that our a is going to be 1 and b must be 2. So let me box that because this is some important information that we must know. And since we already got an a and a b, I think we can compute the value of c. So let's just do that real quick. So if I switch around the equations, we're going to have c squared equals to a squared plus the b squared. So we have c squared equals to, what is that, 1 plus 4, which is 5. So c is square root of 5. Have we seen square root of 5 for every single example that we have done so far? Oh well. All right, so now I think we're ready to put everything together. So let's first compute the center. So center is h comma k. So in this case, we get 2 comma negative 1. All right, now who's next? Foci. Let's deal with the foci. So the foci formula is h comma k plus or minus c. So here you're going to have 2 comma minus 1 plus or minus, our c was square root of 5. So this is 2 comma negative 1 plus square root of 5. and then 2 comma negative 1 minus square root of 5. Okay, so what should we do next? Vertices? Alright, so the vertices formula is h comma k plus or minus a, so which is 2 comma negative 1 plus or minus 1. So it looks like we're gonna have 2 comma 0 and 2 comma negative 2. Now let's find out the asymptotes. The formula is y minus k equals plus or minus a over b, and then x minus h. So that will give us, let me see, y minus minus 1, so y plus 1 equals 2 plus or minus a is 1, b was 2, and then x minus h was 2. Alright, so I'm gonna box this for the asymptotes. Now let's deal with the box. Okay, so how are we gonna draw the box? Well, we must go up and down by 1 unit. From the center, of course, from the center. And then we must go left and right by how many units? 2. Alright, so on this page, I just inserted the graphing paper and then I just rewrote what we just found out. So I don't have to go back to the previous page. So let me just start plotting some points here. So the center is at 2 comma negative 1. So this is center. And our foci is going to be 2 comma negative 1 plus square root of 5. So the square root of 5 was approximately 2 point something, right? So 2.2 or something like that. So here, our approximate foci is going to be 2 comma, so negative 1, and then you add like 2.3, so that's, what is that, like approximately 1.2. And then 2 comma, so negative 1, and then minus 2.3, it's approximately 3.2. Okay, so if I plot that 1.2 maybe right here, so I'm gonna denote this as 1 focus, and then negative 3.2, 1, 2, 3. Does it look equal distance? All right. Okay, so those are my foci. Now vertices is at 2 comma 0. And then, where's the other one? 2 comma negative 2. All right, now let me draw that box. So where was the center? Center is, God, there are so many dots going on. Center is right here, by the way. So this is our center. So from the center, we're gonna have to go up and down by 1. Left and right by 2. Alright, so let me just make the box. Now here's the box, and from the corner to corner of the box, I'm going to draw the asymptotes. Alright, so the one with the positive slope is y plus 1 equals positive 1/2 x minus 2. Negative slope is y plus 1 equals to negative 1/2 and then x minus 2. Alright, now the graph time. So let me just do the best I can. So oh my goodness. Well, I did the best I can here. So please pretend that that is the beautiful hyperbola, but This is our graph for y minus 2 squared over 1 minus x plus 1 squared over 4 equals to 1. Alright, I am done torturing you for the day. So if you have any questions at all, please let me know. And great job everyone, and keep up the good work.